Okay, we finally got this sound working right. We have been putting our interactive notebook, our spiral notebook together. We should be on this page. It's the 1-2 measuring segments. This is how it looks. This is how it should be in your spiral notebook with space at the bottom here for us to add some examples. And when we do that, this was the PowerPoint that you need some space on the other page when you flip it over. So, but starting, I have highlighted key information. So whatever I have highlighted, please make sure you get this into your notes. I'm not asking you to copy everything, but please copy the additional information I'm going to put on the Smart Notebook because you have some extra things you need to know. No. All right, so first of all, we will use the segment addition postulate whenever you see a point between or whenever you see that word between. Okay, couple things. Between, make sure you know, between does not mean middle. Oops, I spelled that wrong. Let's see if it's going to erase. Hold on. Probably not. No, it's not. Sorry again. I have to go with the old-fashioned way. Right here. Does not mean middle. All right, good. There we go. I wonder if I can change that pen. All right. What it does mean is that whenever I see that word between, I will be using the segment addition postulate. And the segment addition postulate basically says right here, B is between. I'm going to put a little arrow. That segment right there is between, and this is my abbreviation for between, A and C. Okay, so meaning it comes after A and it's before C. So does not mean middle. Okay, that's a special case which we're going to get into. But with the segment addition postulate, it says that if I have a point between, then it creates parts in the segment. So I can state that AB, that first part, okay, from A to B, plus the next part, which would be B to C, it would equal A to C. And A to C would be our, basically, this represents this little solid, the whole segment, okay? This is the whole. So we're going to add the parts to get the whole. So whenever we see the word between, or we see a point in between two endpoints, we're going to add the parts to get the whole. Now, here's your little example, some things you need to know or to add when dealing with a problem is make sure that we always label our given information. So when we solve, we will always draw or label. And I'm going to put draw because sometimes you have to draw. Draw and label the given information. I'm going to abbreviate that. So your given information here is this right here. And once you label, you can start answering things mentally because you can see a spatial representation on the figure. So if I start with what was given here, I'm going to use some highlighters. And if you can, you can. If you can't, I understand. So I have first Q to S. So I'm looking at this segment here, okay? And then I also have the segment, let's do, it should change, what is it, Q, is that Q? Q to R. Oh, I just realized what I did. I labeled the first one wrong. That's the bad thing about videos. Oh, I hate you. Whoa, whoa. Bad thing about videos is that I don't hear sometimes the feedback. So we're going to have to get this little thing, fix that, because that's not Q to S. That's my fault. Q to S is actually the whole segment. So I'm going to create a little bracket to identify that. So I'm going to just kind of go above Q to S right there. And then go back to my green. That's Q to R, that part right there. And they want to find out R to S. So R to S is what we're trying to find. That's our unknown. Or we can say that is our X. Okay, that's what we're trying to find. But we know Q to S is, the whole thing is 7. And we know that Q to R is 3. So you can physically see that the other part has to be 4. Okay? And so something like that, no, I'm not going to ask you to set up an equation. I know you can work that out. But there are going to be times if we go to our next example, which you have to add into your notes. So back to what I was saying, let me go back. This right here, we're going to add this next example below here. below our given part. So in a segment addition postulate, we're going to add what I've highlighted. Please add the title. Please add the little box example. Please add what I've highlighted that describes it. Now, you can pause the video to do that, but I'm going to move on to example 1. So if you need to still do that, go back and then pause the video. On example 1, this is where I was talking about we're going to have to draw and label, because this is the type of problem that we're going to test your understanding of what the segment postulate is. So if I start off with what's given, I'm going to use different colors so you can denote it. Make sure, let me check something. Okay, that one works. I'll fix the green though. Segment AB. Okay, segment AB is from A to B right there. And it's represented, it equals, its measure is equal. AB, the distance. AB, whenever it's the letters are side by side like that and no symbol above them, it means distance. AB is 3x plus 2. Okay, so I'm going to put that there. Then if I look at my segment for BC, the next segment, so from B to C, that's my green segment here, that segment is 18 units long. We don't know if it's centimeters or inches, but we know it's 18 units. And then A to C, let me check something real quick. Okay, that one's right, so I gotta fix that green again. Now to do that, I can just draw a little bracket underneath showing I'm going from A to C, or I can do it above, okay? But A to C, I'm gonna label like such as 5x. So the segment addition postulate states that because B is between A and C, then I know AB, that segment, plus the next segment, BC, equals the whole segment AC. So that is your segment addition postulate. So if you were to give me something like this, I would give you credit for that, okay? If you were to label, I can give you some partial credit for that. These are things you need to know how to get as many points as possible when I quiz and assess you on a unit. So if you understand the relationship, then you can maybe go ahead and jump to the equation. We know instead of writing AB, it's represented with 3x plus 2. And then for BC, we know it has a measure of 18. So I'm going to substitute that 18 there. And then we also know that AC is 5x. So you could go ahead and substitute. And if you show that substitution correct as well, I can give you a point or two for that as well. So we're going to extend this page just a little bit so we can see everything. Back to right there. Now, here we're just going to solve the equation. So these are the algebra skills that you might need to practice. You might need to come to tutorials for if you need additional help and you don't see what to do. We should hopefully see that I can go ahead and add 2 plus 18. I can combine that like term. So I have 3x, plus 20 equals 5x. And then I'm going to solve for x, and to do that, I'm going to subtract 3x from both sides. I know some of you like to show moving it, but make sure you have the opposite when you do that. The 3x cancels out. This leaves me with 20 equals 2x. And then to solve for x, because that's saying 2 times x, I got to do the inverse, which is 2 divided by 2, because 2 times inverse of multiplication is division. And 2's will cancel out. 20 divided by 2 is 10. And then I have x equals 10. So once we have solved for x, then we need to make sure we are answering the question. So sometimes you might need to circle that, because this says right here, determine AC. So to solve for AC, AC was the expression 5x, 5 times x. So I know what x is now, it's 10, so it means 5 times 10. So I know AC equals 50, sorry. Okay, so that's what we are doing to receive full credit, boom. Now, on our next example, I do need you to copy this down. You can pause the video to get it copied, but I'm going to go straight into explaining it. So get it down so you have it. We're going to pay attention to the key word, which is N is between. Whenever I see that word between, you need to be thinking addition, segment addition postulate. So I need to draw an example of if N is between M and P. So I'm going to add the endpoints M and P as such. And I'm going to put N between them. So it doesn't have to be in the middle because it doesn't necessarily mean middle. It just needs to come after M and before P. So there we have that. And now I'm going to go back into labeling like I had before. So MN, this first segment, that's going to represent my 6x plus 5. And then NP, my second segment, my segment part of the whole, that's going to be 2x plus 3. Yeah, I got to fix that. And then last but not least, the whole MP, so all the way from M to P, will be 30. Okay, so here our question, they want us to find MN and MP. So I'm going to circle that, so make sure I come back to that. So when I plug in my parts, I know since I'm dealing with addition, the segment addition postulate states that I'm going to do MN first segment plus the next segment, and P will give me the whole segment. Now, if you understand what you're going to do, and you already know it, and you just go straight to applying it, you can. Just go ahead and straight into substituting. So I know that instead of writing MN, I have 6x plus 5. Instead of having NP, naming the segment NP, I know NP is equal to the expression 2x plus 3. And it is equal to MP, which has the value of exactly 30. So now we are going to combine like terms again and solve for x. So when we combine like terms, we got to get our x's together, which is right here. So that's going to be 6x and the 2x together. And then we're going to put our constants together, which would be our 5 and our 3. Now you can do this mentally, and that is just fine. So 6x plus 2x would now give me a total of, excuse me, let me scroll up just a little bit, 8x's. 5 plus 3 is 8 equals 30. So when we solve for x, we're going to have to subtract this 8. Subtract this 8. 8x equals 30 minus 8 would leave me with 22. And then we're going to divide by 8. Divide by 8. You can simplify when you divide, and you would get 11 over 4. I will accept that. Or you can give me the decimal answer, which is 2.75. Okay? So that is our value for x. But what we circle said determine MN and MP. So we need to find the values of that. So MN we know was 6x plus 5. So we're going to substitute 6 times the 2.75 plus 5. When I work that out, I get the MN, excuse me, is 21.5. So we're going to work smart, not overwork. So what you need to do is think about this. If I already know that MN, and if I go back to our picture up here, I already know that this little part right here is 21.5, okay? Then I could just do what to get that missing segment? Exactly if you said subtract it from 30, okay? So go ahead and subtract it from 30 and give me the value of NP. And now when I check for your notes that they have been completed, this is what I'm going to be looking for. So you know what, so how to get assessed. All right, so add these two examples. I'm going to go to the next slide. And you need to add these examples as well. Now here, let me scroll this out, sorry, so you can see. Come on, recorder. Oh, you're not going to close. All right. I need you to copy down the midpoint, what I've highlighted, and the definition. We also, let me see if this will work now. There we go. We're also going to need you to draw this example. Sorry I didn't highlight that. But there's a couple things I need you to understand. So first, the fact that we have some markings over here. These hash marks, and I'm going to point to them. Add this to your notes. Right there and right there. Okay, so anytime you see markings that are the same on a figure, it's showing a relationship. And so those hash marks are showing that so the hash marks show congruent. This is the symbol for congruent, an equal sign with the little sideways S on top. Segments. Okay. Please be familiar with our symbols because I won't write words out. I'm going to be using symbols. That's what we do in geometry. So if I see those tick marks, then I know that M is our midpoint. Because if I have two congruent parts, two congruent segments, then the point in between them has to be the middle, okay? So we got that. And then, go ahead and pause the video if you need to. After I explain, I'm sorry. Pause the video if you need to. Go ahead and copy down what midpoint does. It divides the segment to two congruent points. And that the other word for midpoint is bisects. And so it tells you a bisector could be a midpoint, any line, array, or other segment. So if you see the word bisects, please be familiar that it is similar to, and that's the symbol for similar, to midpoint, because it has to go through the midpoint to bisect. And that's how I abbreviate midpoint as such. So basically, our bisector is that point O, because I see these tick marks. Without the tick marks, you can't prove midpoint or bisector. Now, the things we want you to understand whenever we see midpoint or the word bisect. So whenever we see these two words, these are the two relationships that we should be coming up with. One, that DO, in this example right here, it's half, because it bisects, DG, the whole segment, okay? I could think that. I could also think, I could go backwards. Instead of saying half, I could say, well, if I double DO, if I double the divided segment, it will equal the whole DG, the whole segment DG. And that is true also for OG. Some of you have some OGs, maybe not, probably not. Okay, so I can say 2 times the segment OG, and it'll equal to the whole segment DG. So add that to your notes, get that down. And also, let's get this example down, because this is going to be our last little example dealing with midpoint. And then we're going to talk about the coordinate plane. So go ahead and pause the video, get this down. I'm going to go straight into explaining how to solve it, okay? So if you need time to get the information, pause, and then come right back to me. All right, so on here, we are using the diagram and using what's given in the words to come up with an equation or relationship to solve it. So this is very important. Whenever I see this word midpoint, I need to be thinking to have some type of congruency, okay? Some type of relationship. Congruency is the same as equal, okay? So I need to also be seeing tick marks, and they have already did that right here. Tick marks here. So I'm always going to label our given information. They start off and saying if x to y is 16x minus 6. So that is this whole segment, 16x minus 6. I know that, and now if I know that u to y is 4x plus 9, so this is this little part right here, 4x plus 9. They want us to find the value of x. So the question is find value of x and the measure of x, y, okay? So if I know, and I apologize, let me try to fix this. uy is 4x plus 9, and it has a tick mark. Well, there's a tick mark over here, which is xu. That is also 4x plus 9. So there's two ways I can set this up, okay? If I know the two parts are equal, and I know the whole segment, excuse me, then I could say 4x plus 9 plus 4x plus 9 equals the whole segment, which was our 16x minus 6. You can do that. Or I want to work smart, not overwork. So I know I have 2 of the 4x plus 9. So let's say just 2 times that. I got 2 groups, 2 amounts of 4x plus 9. So 2 times 4x plus 9 is equal to 6x minus 6. This would, either one will get me to the answer. So the same answer too. So I can distribute. So if you look, I'm adding those 4x's. That gives me that 8x. Add my 9's plus 18 equals 16x minus 6. And now I'm getting into solving the equation. So I'm going to scroll this down. Oops, 6 in the page. Oops. So to solve our equation here, I want to start with the smallest variable because we got variables on both sides, a variable on the left side and the right side. So we're going to say minus 8x, minus 8x. 8x is going to cancel out, leaving me with just 18, a positive 18, just 18. Now I have 8x again, 16 minus 8 is 8 minus 6. Well, I still haven't isolated the x on the other side, on the right side. So now I'm going to have to add the 6 to isolate it. I got to get rid of it, do the opposite. So since this is minus 6, you're going to add 6. It becomes 0. 18 plus 6 will give me 24 equals 8x. And now we can divide by 8. Oops, I wrote 3. I don't know why I did that. Probably because I know that the answer is 3. So 3 equals x, or x equals 3. So that's the value of x. But they also want us to find the measure of xy, which is up here. So xy, we know x to y was 16x minus 6. So we are going to plug that in. We're going to do 16 times 3 minus 6. Well, we get 48 minus 6. So now you can tell me that xy, is 42. Okay? And we have solved the equation. Good job. Pause, rewind if you need to. That is pretty much taken care of when you have to write an equation and use the segment addition postulate or midpoint on to solve and solve for x to find the measure of a segment. So thank you for taking care of this. There's going to be another video helping you for the next set of examples. So if you need more room, because remember I said I wanted you to have room here to add some more examples, you can do it on a separate sheet of paper and we can just staple it to it. But our next example is this one here. I'm going to stop the video. You need to go to the next video to walk through this example with me. All right, thanks.